can differ from each other, and that wedge or cone between the two prices creates a region where people might have different beliefs, and you can imagine the secondary market price moving around within that band. But if the price pushes up at the top of the band moves up. If it pushes down, it moves down. And I find this to be the simplest example that helps us understand the asymmetry in the way different mechanisms realize different prices, and helps kind of unpack this idea that price is a bit more of a distributed thing, and that our notion of price in the market sense, like the change point on, say, an order book, or the spot price on a Uniswap, is actually just it's like a sense-making thing. It's an estimate of the centroid of some messy distributed thing that represents people's individual beliefs, but those individual beliefs are not completely random. They're in part their own inferences based on their interactions with the various mechanisms that realize prices. But I'm going to stop because I feel like we could do this for hours. In fact, maybe sometime we will. But it's not the main point of the discussion. So we'll work with the price model we have, but just keep in mind that's a highly sensitive point for a lot of models.
Yeah, that makes sense. And it may be that if the model is looking at different things, we need to completely change how we're thinking about price. But I guess in terms of the relationships here, we know that as inflows increase and the token supply is constant, price goes up. If the opposite happens, price goes down. And if we approach zero supply, if we remove a bunch of stuff from circulation, price goes.
The only thing I'm saying is, instead of changing the price directly, I would change it to something like a martingale, where the variable compute is actually the expected price change, as a percentage, and that you've basically flip a coin with a distribution around that, so that it's noisier and that it can kind of trend up or trend down. It will always trend. In expectation, it will trend in the direction you want because of the properties of martingales, and it can get a little bit tricky to get the hang of making martingales work. But if you do get the hang of making martingales work, I think your models will feel a lot more realistic, and the Monte Carlo component will make more sense because you'll see more bands and get a better sense of how it might go, rather than getting sometimes results that feel overly deterministic and don't feel realistic.
Yeah. I think we can table that and come back to it, because I have a question eventually that I want to try and understand is at what point and what parts adding non-deterministic processes into the model and doing Monte Carlo sweeps actually.
So we will peg it, and I will say probably here is probably one of the first places you'll want to do it, because we don't have a lot of certainty around, so it's a good place to fuzz it out.
It can be fairly accurately modeled as a random walk around some expected value, though, right?
That's what a martingale is.
Oh, okay.
Yeah, so yes, and I guess that's what I was saying, but in math words. Yeah, there's a martingale, and there's other concepts called super martingales and sub martingales, which relate to whether the random walk has a tendency in a direction. So, but a martingale has its random walk around an expectation, and then if you think if they expect it, never mind. We'll peg it. You're right. We'll deal with it later.
Okay, cool. And then we have our protocol mechanisms, which is basically our supply policy for minting and burning tokens with the throttle parameter that was in the previous model. We have our outflows determined by a scalar value that abstracts the conviction voting parameterization. I'm kind of going through these pretty fast because they were in the previous models.
Yep.
And I want to jump into the code. And then we have these inflows collected as a result of market saturation that get converted into honey and move from the circulating supply into the common pool each period. And that's kind of the main reason we needed price in the first place, was to be able to do that conversion. Cool. So then once I had that, I just started specific cases, just throwing numbers at it to kind of see, to spot check how things were like looking and whether they made sense. So the first one I looked at was like productivity parameter being 0. And this kind of gets us back to the like max issuance, like throttle parameter projection, which we sort of expected to see and looks kind of like the previous model. And we see price steadily declining, which sort of made sense. And then the success case, which is a little bit more interesting, where we reach market saturation. We saw total supply and like reserves in circulation all kind of going down, and there's this like inflection point where the like reserves go away from their target and they invert with circulation, and you see like price going up and then kind of steadying out after like the kind of market saturation point. And then like in between those values, there's like different levels where you plateau at different market saturation points that are either like eventually like stabilizing with price increasing or like supply decreasing, but they kind of like they're somewhere in between. It just sort of like modulates.
Right. Yeah, so I think one of the things is that the deterministic analysis is going to be prone to these sort of like static equilibria, like that you could characterize the system in terms of what the sort of steady state dynamics are. But in real systems, once you start introducing stochastic elements, you're going to have this slightly different thing where there's these sort of non-equilibrium dynamics that it's not always clear whether it can like things can like break out of one level set and jump in, and then a little bit. And it's hard to tell until you start looking at Monte Carlos with stochastic process elements. But like some of what you need to watch out for is systems that have there's sort of like a disjoint between the deterministic steady state and the sort of the bubbles that the stochastic systems actually fall into. This is, I guess, kind of one of those slightly more advanced concepts that shows up when you start dealing with stochastic dynamical systems, but it's just you have to be like it's always good to do the deterministic ones as sort of first pass, but like until you have some stochasticity, you have this risk of like finding equilibria that don't really exist. Meaning, you see them in the deterministic system, but they're somehow like inaccessible, or they're not actually all that stable when it comes to noisy systems. And it's not always the case, but it's something like I want to be really careful of inferring too much from the deterministic models, because they might inherit a lot, for example, from that price model that you showed me. I don't know for sure that it does, but like if I were to pick a different price model, or if I were to use a price model, or like start to mess around with those things, I'm not sure whether you get the same steady state convergence dynamics, and thus I would hesitate to make final decisions or policy decisions based on just the deterministic models. Does that make sense?
Yeah. So I'm just adding it in next steps to like implement some stochastic processes, perhaps the pricing function, and then kind of see how that like change in assumptions changes our results.
Yeah, and to tie into, I think it was Sandpiper's point, it's not necessarily that it's a total random. It can be a random walk that has that has the distribution of the random part of the walk influenced by state variables. So if you have a state variable that tells you something about which direction you would expect things to move, when you flip the random walk variable, you can skew the distribution in the direction of growth or contraction depending on those other signals. And so it's by mixing the determinism and the non-determinism that you end up basically fuzzing out the same dynamics. So you might end up using the same signal that you used before, but then instead of using it as the new price, you might use it as the expectation of the price, and then flip maybe a normal distribution with that as the mean, and some standard deviation which you're using to maybe be a volatility parameter of some kind as maybe a percentage. You have to construct the martingale, but if you constructed a martingale thing, who used an expectation based on your calculation instead of using the fast value as the expectation, which is a standard martingale. That new random walk has this sort of combination of your deterministic model and a fuzzing that will help you see whether the thing you saw in the deterministic case will like survive the introduction of randomness. Does that make sense?
Yeah.
Right. It's like the stock market can be basically modeled as a random walk around the average returns, although it's not technically a normal distribution. It's like a long tail, highly skewed distribution, but still, you can kind of approximate it with a normal distribution.
Yeah. I don't particularly like normal distributions as it happens. It's a place to start if you're learning. Like, if you're going to learn how to use processes, I generally would say something like starting off with a normal distribution, it's a lot easier to kind of get the hang of. But yeah, to your point, for one thing, if you're doing distributions of percent changes, normal is already kind of not normal, because what ends up happening when it propagates is sort of the linearity effects that come from another one of these things that is going to be a pain in the ass to get into. Okay, you should probably just play with distributions and see what feels right, and we can talk about it more later, but to the point made, normal distributions aren't really the right distributions for this kind of thing, but they're a decent place to start. And then when you get into it, especially if you look at historical data, you can actually back out like, we've actually plotted histograms of percent changes of price movements in cryptocurrencies, and then used that to estimate the shapes of probability distributions, and then like sampled those probability distributions instead of using like a normal distribution. That's actually what we do for like some of our like climate models and stuff. It can be kind of a pain, but we started off actually like 2 odd years ago, where we just like grabbed the historical Ethereum and Bitcoin data, and we took those data sets, computed the per period percent changes over a range of period lengths, created sort of parameterized stochastic processes, and then Andrew ran some. He basically ran for some client projects stochastic processes that were like the generators fit from the historical data we had at the time. And like when it push comes to shove, that's probably the best way to move towards realistic. It's just like a weird kind of realistic, because it's not realistic in the sense that we did the same as the past. It's realistic in the sense that the randomness has the same statistical characteristics over time that the real past had.
Is this really even necessary for this model, though? Because
not at all.
We can easily like do the dynamic model without such a realistic model.
Yes,
right?
Absolutely. We do not need to do this for this model. I get kind of caught up in like, if you wanted it to be realistic, but you're right. In this case, I wouldn't go that way. Like I said, I would have probably started with something as simple as like doing a martingale, taking the mean and doing like a normal distribution with a, maybe some variance as a function, like just like a some fraction of the mean. So like, or some like simple heuristics to construct this sort of martingale process. But 100% agree it's not necessary for this model at this time. But that is what you would do if you were expanding the richness of the model over time. Sorry. Cool. Thanks for checking me, by the way, because I tend to get excited with the more fancy stuff. But we don't need to do that. You certainly don't start there. You add complexity a little bit at a time, and you prune it out when you don't need it.
It's definitely it's definitely interesting, though. Like, I get that.
Yeah, I mean, I guess from here, and we're limited on time, in terms of like next steps, because one of the goals in the short term is we've got this like issuance policy. We started working on like verifying the implementation. We're going to have to set 2 parameters, and ideally we set them with a strong degree of confidence that we're not going to have to change them.
What I think you actually want to do in practice then is the only thing that I saw that was like I think needs to be fleshed out a little bit is you need to fuzz out the pricing model, the sum, because it's going to like dominate the outcomes. So if your pricing model you're almost better off with a complete stochastic process than you are with an overly deterministic rule, because there's just so many external factors that could affect pricing. But I get that issuance is going to affect price, so you can imagine even something as simple as well, I guess it's basically what you did, looking at the revenue generation relative to the rate of change of supply, using that as think of it as sort of a pressure that skews the expected change in price, and run it like that, and use that version of the model with maybe some parameterizations around like how big the random is relative to the sort of signal. Like, so basically how big the variance is around that. Something like that would help make sure that the kinds of equilibria that you're achieving and that you're actually thing are a little bit more robust. And so at that point, it would, even just that one place introducing the randomness would give you the reason to both do parameter sweeping, for example, around the volatility, and maybe Monte Carlo, since it's got some random results. And you would plot like clouds to kind of see the sort of distribution of what happens over your Monte Carlos, which policies you like. You can kind of look at the clouds relative to each other, and they might overlap a little bit, but you'd pick the ones for which you're kind of happiest with the dense part of the cloud.
Gotcha. Okay, so that seems like doable next week. I can experiment with the stochastic processes for the pricing, and then like set up like better plots for the Monte Carlo and parameter sweep stuff, so that we can like visualize the like different runs against each other. And then does the like line of reasoning that I kind of outlined here, where we would like probably try and prefer like values where we get the like greatest range of, I guess, successful results based on
I would generally bias towards a kind of min-max selection. When I say min-max, I mean like make the worst thing the best, as opposed to making the best thing the best, or even making the average thing the best. Whenever you're dealing with high uncertainty scenarios, it's sort of prudent, especially when like safety, sustainability, and security, these kinds of things are your metrics that you care about, to basically try to make it work as well as possible in the worst case scenario. Sometimes that can be tricky, because if you make a scenario that's bad, it might be impossible to make it work good. But like in the worst reasonable scenario, like in this case, the worst reasonable scenario is going to be something like, well, your ability to produce revenue happens slower and later than you thought. Because if you're anchoring this on this exogenous process that says we successfully converted expenditure into utility, and utility as revenue, that part of this model, that's really your driving process. So your worst case scenarios from a like exogenous perspective are the ones where you are the least efficient at turning money now, future money later, and that will probably manifest as you're expending money to build stuff that requires lots of maintenance, meaning you spend a lot of effort just keeping the stuff you have up and running rather than making stuff or accessing new spenders. And so it's actually going to be within your best interest to spend a little bit of time parameterizing that chain of events that we talked about at the beginning. I think it's the right chain, but like maybe doing the diagram and maybe like reasoning through what parameters sort of represent a kind of efficiency. And you don't necessarily have to break it all out and make it complicated. If you wanted to, you could collapse it actually and just say there's one efficiency value, and that efficiency value is as simple as converting money spent into sort of some generator of money later, right? So if you imagine revenue as being something that you, even if you sampled it or even if it was deterministic, in a sense, you're accumulating a production rate. So if you spend money, you build up something that determines the rate of new money inflow. So if that's efficient, then each dollar you spend creates a bigger pipe of money later. And if it's inefficient, then each dollar you spend now produces a lot less of this, rate of new money later. And if you can kind of hone in on this idea, you can kind of start to flesh out maybe something like best and worst scenarios, where best scenarios are we're really efficient. For every dollar we produce now, some months from now we would for every dollar we spend now, then in expectation we're going to produce so many dollars per period later. And again, that kind of relation, the expenditure to increase the capacity to produce money later, is like the minimum viable sort of parameter that represents the efficiency of the community. And if that's real low, this is going to struggle, because if you're minting almost no matter what you mint, you're going to mint faster than that thing produces, and you might tank your price. But if this thing is really efficient, then of course you're going to see higher prices, you're going to see more growth, you're going to see an easier problem to manage from a resource management standpoint. Does that make sense?
Yeah, so I kind of have this like productivity parameter that I think basically does that. And what I was thinking was, because the parameter is just like a number, it doesn't really correspond to anything like intuitively. We would just want to find like the parameters that give us the greatest like range of acceptable values for that kind of parameter.
Right. Yeah, and you could work towards making it more by like refining the modeling, not even the modeling component of that, because what I'm describing is sort of kind of breaking it down into something a little bit more intuitive, but it's tricky because it's a signal processing way, because I'm not really talking about a computation in one moment. I'm talking about the relationship between essentially a lagged and attenuated signal, because you're not you're and actually it has a sort of integral derivative, or like a differential order relationship baked into it. So it takes some effort to kind of get from, okay, I understand this phenomena, to I have a mathematical model that's pretty realistic and ties into real things. But it's basically, and I know I sort of rambled this once already, but if you think of it as the relationship between money spent now, but you spend it, once. So in this time step, I spend money. But what it does is it creates or increments something that represents the capacity to produce money later. Operator. It lags a lot because you're not going to get the benefit of it until later. But later, you're actually going to get not a one-time inflow based on that, but you're going to get a flow rate that's increased based on the accumulation of what you spent now. And this is the kind of relationship that business dynamic book helps you map out. And in fact, because it's kind of businessy oriented, these kinds of relationships show. Just part of the reason I recommended it. It helps you build mappings between like mathematical representations of rates of change and accumulations of things to like more intuitive concepts, or even things that you could define and measure, at least in retrospect. Because although we might not be able to do this at the upstart, think of it like story points in Scrum. Like, okay, you don't know what your velocity is because anything, but after a while, if you have enough data, you can look at how your team measures story points and how it manifests as velocity, and actually start to do some realistic planning. But until you've done it for a while, the data is meaningless because you don't know a priori how much a story point is.
Got it. Yeah, makes sense.
Like, actually, one of my teams is building a model of a Scrum process as part of one of his business models for a company we're working on, and he's actually getting set up, integrate it with Jira, so that we can actually do a cadCAD model version of what I just said. The story points and feature development productivity rates as a cadCAD. See, maybe he'll even open source it eventually.
That'd be cool.
Well, so he's using it. He's using it as part of the planning for the Labs platform. So for the people who don't know, we're trying to build a web-based utility to make a lot of it easier, manage workflows and collaborations, because notebooks are kind of a pain in the ass. If you haven't noticed, collaborating on notebooks sucks. So we're trying to build some tooling that makes it easier to do, a little bit of sharing drawings and the kind of that Luke's sharing. So it's the notebooks, it's the code, and it's the markdown files, and try to help kind of manage the workflow. Not that you need it. It's not like you can't do it with the free tools, but we figured one of the ways to revenue is to bundle things up and ease the UX and provide some cloud-based computing. So that's under development, and the person who's leading that initiative is a recent cadCAD user. He's a product and analytics guy, worked in industry for a long time with me in the past, and he started using cadCAD for the first time, and he's built out these cool models of adoption funnel, dev production and stuff. So hopefully, as he gets the platform running, he'll be able to our team will probably help, but factor some of those models into a format that they're more of a template and less of an internal tool. And that point, once we've gotten our own business data out of them, we can put them in places other people can use them.
Nice.
So of course I wasted all of our time yammering. I hope that's helpful.
Okay. It was definitely helpful, and there's some kind of clear next steps. And I know we didn't get to dig into the code too much, but if you have a chance to review at some point,
I'll probably run it this weekend. I did want to do. Like I told you, I got pulled into these presentations last minute, and I had to prepare them.
Yeah,
because of course I sound like. Oh, sorry. I was saying because I'm totally not concise if I don't prepare, as evidenced by this discussion.
Yeah, I was just going to say, and I know you probably have to leave for your thing.
I have
yeah. Okay. Yeah, I think Sandpiper left, but we've got a few other people here. So if anybody's interested in kind of working on this iteration this week, let me know. I want to explore the stochastic processes and the other stuff we kind of talked about in next steps and clean this up, but would love to collaborate with people if people are interested.
Yeah, that would be awesome. I know Barada's been doing some stuff. It looks like he shared. We've been talking on once a week roughly on modeling, and he's looking at, actually to your question about diagrams, he was looking at Figma and working on some diagramming templates, which I'm sure he'll share when they're mature enough. But yeah, I think there's
on Figma of the differential spec diagram, and I actually maybe I have it up.
Yeah, the thing about the differential spec is that I just don't think it's quite over the threshold yet. I sort of made the original differential specs in a slightly hackier way. I made them because they were what I needed to plan my code. And I think that they inherited just a little bit too much, and that they need to be kind of broken down and reconstructed in a very similar way. I mean, they contain the components like decision making at the top, and then the logic that transforms the decision into changes to state, and then any sort of metrics that are functions of state. And then you can think of all of that information as being an input to the next layer. So they do have a nice. They're actually a lot like different equations, just in drawing form, and you can actually write differential equations that match up to them if you do this sort of math specking type of thing, which I often do with my team. But in part, the reason I do math specking and differential specs is because at least some of the time I'm designing without being the coder, and so it's a good translation interface. I spend time making the diagrams and the equations, and then asking somebody to implement it, and then I sort of collaborate with them once it's up and running. And that's a streamlining that's maybe not realistic for all workflows. So it's in a way, differential spec was inherited from workflow. And so the question is it the best diagram? Is there a better diagram? So, insofar as people are getting engaged in this kind of modeling, don't be afraid to innovate on the diagram formats.
Yeah, I mean, for me, there's there's a value from a learning perspective in having relatively standard formats for some of these things, just because it makes it easier to compare and absorb. Not that they're necessarily perfect, but if they're standard, there's a value in that.
So in a way, that kind of comes down to growing community, because it's a pretty young community. They can be, if people find that they're effective, then treating them as standards and reuse is fine. There's nothing wrong with them. I'm just kind of throwing out there that they're de facto standards because they have been used. So at one hand, use them if they're useful to you, but if you don't find them useful, then just don't be afraid to mutate them and post something on community.cadcad.org that says, hey, I made a minor change to the way I build my diagrams. What do people think?
Yeah, that makes sense.
Yeah. Anyway, honestly, we've said before, I'm here to teach people because I want to see more cadCAD. people to like actually just introspect on their own policy making. And even if it's not going to give you perfect objective answers, because it probably won't, it just gives you some like better understanding of the potential ramifications of your decisions. And I personally believe this is critical for governance in this kind of like DAO ecosystem, that because the policy making is predominantly algorithmic, if you can't find a way to engage people in the discussions and actually say, hey, like if we do this, these are the kinds of things that might happen. You guys cool with this? Otherwise, it just devolves back into governance by experts. And I'm like, believe it or not, like not a fan of that. I just want people to be informed enough to participate, because the other problem is it's like crowdsourcing, madness doesn't actually go anywhere. To try to interpolate between small group of experts trying to govern versus everyone sort of trying to govern but not knowing what they're talking about, my answer to that is build tools and frameworks that allow people to engage with each other to come to collective decisions with realistic expectations about what we know and don't know about the consequences of policies.
Yeah, I mean, ideally for me, we just minimize all of the governance entirely. We just do it once and then we're done.
Well, but so this is hand in hand. Governance. So like when we use the automation as our path to governance minimization, that's real, but it's still not governance removal. What we've done is we've put algorithm design in the role of governance. It didn't go away. We just set a policy that was an algorithm. So you still need people to be able to participate in that policy-making act, that governance act, but it's minimized in the sense that the frequency with which you do it has been radically reduced because it's been implemented in an algorithmic form. So it is governance minimization, but it's respecting the governance surface that's left, taking it seriously.
Yeah.
But I mean, maybe this is an ideological point, but I don't believe it's possible to completely remove it, because at that point, you're not actually in a democratic environment, one where people actually have input over what they live in. So if we want to maintain the sort of agency over the system of rights that we live within, we have to retain some governance surface. But we can minimize that governance surface through automation, at which point we need to have tooling through which to agree upon the policies that we're going to bind ourselves to.
Yeah, I mean, I don't know if permanently having agency over systems is necessarily desirable. In the sense that, like, if we think of these things, and this definitely goes down the philosophy angle, and we don't have a lot of time, but if we think of these as, like, institutions in the same way that, like, I don't know, physics is like a institution in the world that we live in, the fact that nobody can touch that is not necessarily a bad thing.
Yeah, but see, I would argue that physics, as we know it, isn't actually untouchable. Its boundaries are really, really big. Like the circumstances under which we critical physical laws is extremely small. Meaning, you'd have to approach quantum or relativistic scale before the laws break down. But it's still necessary to understand that at some point you change which set of rules that you apply to context. The bigger the context in space and time, the more that surface is minimized. Like, you don't have to care. But the thing is, you always eventually care. There's some boundary. There's no like absolute model. It's just, the idea is we want to minimize governance by getting something whose boundary is really far away and slow moving. Like Newton's law is a great example, right? Are we likely to ever care quantum or relativistic? Probably not. But if we hit that boundary, we know enough to revise which model we're going to use.
Yeah, that's fair.
Anyway, so there's the philosophy bit. Maybe we should have a philosophy cafe session sometime soon, because I find it really fun to talk about the philosophical aspects of DAOs and governance with communities that are actively practicing. It's a lot more fun than having it with people who are not actively practicing, this kind of thing like One Hive is.
Yeah, that would be a lot of fun. We should get Griff on there too.
For sure. So I'm good for the day. I'm going to log off. But if anybody else wanted to say hi or ask a question, I'm hoping this is like productive for people.
Yeah, I'm learning a lot from like hearing. Maybe hopefully later on I can give my input, but for now I'll sit aside and learn as much as I can.
Hey, did you guys record the first part of the meeting or this?
I did record the first part.
Hey, awesome, appreciate it.
Yeah, no problem.
Cool. Yeah, if you share the recording later, we can also add it to the wiki. I'll plan on spending some time to like update the like Luna section.
Yeah, sure.
All right. Well, Luke, enjoy your latkes, and I'll try to catch you sometime next week. And I know it's like a little bit laggy, but like the holidays, since this is kind of extracurricular for me.
Yeah, no worries. If you have a chance, can you share that document that you were talking about as well?
Oh yeah, I think I can dig it up now, or hopefully if I can find it in the next 8 minutes. But I'll
after or whatever. If I don't get it,
if you don't get it,
tonight,
ping
I'll
me.
ping you.
Yeah. Perfect.
All right.
Thanks.
Cool. Take care.
See ya.
Bye, guys.